Welcome back, team.
Coming to the dynamic volume provisioning team, so we should understand the process here first. See, in the static volume provisioning, what exactly we achieved, team? First and foremost thing, you created a storage class. On top of it, you created a persistent volume, right? You have used the storage class reference inside the persistent volume. You will use the persistent volume reference inside the persistent volume clamp. You will use the persistent volume clamp reference inside the pod YAML. That is how you will establish the connection. So in this way, when the pod is getting deployed to the Kubernetes cluster, automatically pod will refer the persistent volume clamp. Persistent volume is already well bounded to the persistent volume with the help of the storage class. So this is exactly the thing which will be established when you launch a pod team. Okay, that's very clear. And I just want to give another example. Especially, I'm just showing an example. And last session also I showed an example by using Azure files. I'm going to the documentation one more time. Okay, let's go there. Azure AKS dynamic volume provisioning. Okay, dynamic volume provisioning. Let's focus on this particular thing, team. Okay, you can take anything, not an issue. I'm just going for the files. I'm just asking you guys to do the disk homework. Okay, just do the disk homework. Okay, so find him. Now you can sense here very clearly. You just go down, go down, go down. So especially these are the storage classes available, especially for as part of the files. Okay, that is what exactly they define. Any cloud environment concept is same team. Okay, no changes on that. This is what exactly you will create a storage class first. On top of it, directly persistent volume client. Oh, something interesting, right? See, so far our approach was first and foremost thing, we will create a storage class, we'll create a persistent volume, we'll create a persistent volume client, we'll create a pod deployment YAML. That was exactly the sequence we understand so far regarding the static volume provisioning. But in case of the dynamic volume provisioning, the sequence is not true. You no need to go in this way because the name itself dynamic is telling you no need to prepare your actual storage. That one dynamically will be provisioned. Okay, that is the main part here, team. Okay, that one will be provisioned dynamically. But the point we should understand how it will be provisioned dynamically. So that part we need to see now, team. Okay. So to see that how exactly it will be provisioned. Now let's simulate the case, team. Okay, let's go back to the percent volumes. Here you can double check. Okay, you can double check how exactly this is the statically provision a volume. Okay, that is what exactly we simulated in our last session. All these commands we executed, we just went through each and everything, and we proved the case is really working fine. So that was the part exactly we have seen. But to just implement a dynamic one, okay, I believe the top section is the dynamic one. They started with the dynamic only. So if you just come see dynamically provision a volume, click on this one, dynamically provision a volume. Okay, so we should understand what exactly the dynamic volume provisioning will do. A very simple thing, Tim. If you read this one, a persistent volume climb uses the storage class object to dynamically Azure well. That's it. Simple. The connection is there is no need of persistent volume now. Okay, that is not required. I'm just copying this particular connection, these four connections. I'm just pasting at the bottom, and you just keep this particular thing here. And especially what exactly we need to do, especially this particular persistent volume is no longer required, team. This is not required for you. And also that one will be provisioned automatically. So that's an interesting fact here. Okay, so this particular connection I'm just taking out. Okay, I'm just taking out this particular connection, and directly your storage class will be connected to the persistent volume client, but indirectly PV will be created, no doubt in that. But actually you will not go in sequence. That's an interesting fact. Okay, this is bounding. This thing will happen, but dynamically this one will be represented. So that's an interesting thing. Okay, all right. So now what exactly we need to do here is, okay, so now once we are done with this particular part, okay, what exactly we should do? Okay, so once your percent volume climb is establishing a percent volume dynamically, how exactly the pod is consuming this one? Is there any difference? The concept is same. Let's simulate that one, team. All right, so once you are done with this activity, now I'm just going back here to where is this particular documentation. Our documentation is very clear. Okay, you can refer other cloud documentations also. This is very clear actually. Okay, so you just go there. See, storage class is the one which you know already. These are all the different types of storage classes available for the files. You can refer the disk model and you can see the disk things also. Okay, and if you scroll down, team, first and foremost thing, what they're telling here, create a file name, Azure file sc.ml, copy the following manifest and more information mount option. Something they are just telling, please create this particular SCML. So meaning that one storage class ML they're just asking us to create. Okay, once you create that one, directly he is jumping into the persistent volume claim. Please understand it. But in case of the static, you never do that. In case of static, you just create a static volume, so storage class for a percent volume. But you are not doing this one this time. You directly jumping to here. Okay, that's exactly the gap here. Okay, you just go to the person volume claim, whatever the storage class name you created. My storage class, I created a my-azure file. The same storage class you will use here. This is what exactly I'm highlighting. The storage class name my-azure file you will use here. Okay, that's awesome. Once you are done, create a percent volume claim using kubectl. So now you are creating a percent volume claim. That's awesome. So you created a PVC, but you never created a PV, but it got bounded. It's an interesting fact. It got bounded. So you never created PV, right? But it got bounded. So that is the interesting fact. So you should understand this particular technique, how exactly they are doing, team. Okay, right. So let's simulate the same thing only. Let's simulate the same thing. So far good. Okay, we understand the PV you created. Okay, fine. Now the following I will create a pod use the percent volume claim Azure file. Okay, so now you should understand how that is being utilized in your actual process. A simple thing, they are taking on a GNX image and they are just mounting a path. That's all, very simple. You are just providing your percent volume claim reference here, and the volume mount is nothing but your container path. Okay, this name must be matched with this one. Okay, whatever the name you will define here, that name as it is you need to pass here. That's all, team. So once you are done, you are just creating a file. That's all you are just doing. That's it. Okay, your task is done actually. Okay, your task is done. So you deployed the pod by using the dynamic volume provisioning part. And once you are done with this particular thing, that's all exactly you should implement. Okay, now let's go there and let's simulate the same thing now on prove team. Okay, all right. Now let's go back to the scenario, team. Okay, let's go there. First and foremost thing, I think this is what your VM. Okay, switch on your VM. So once your VM is on, then go for the Kubernetes cluster. Then switch on your Kubernetes cluster. And once your Kubernetes cluster is on, then go for the database and switch on the database also. Right, each and everything we proved now. So just go back to the database. Okay, whatever the database you have, MySQL database, you just go there. And especially if Project DB is your database. Okay, please switch on this one, team. Okay. So so far you are completely sure about how to deploy manifest by using a virtual machine. It's a completely raw model where a DevOps engineer is deploying each and everything from the VM with the help of the VM. But that is not exactly your CI/CD, right? Your CI/CD really not pushing you in that direction. So you should think a little bit different. And also your CI/CD is always expecting you to push by using Azure pipelines or some other GCP or by using AWS. Right? To achieve that one, that particular part also I will show you. Because so far we did each and every deployment with the help of the VM. So let's go there and let's habituate how exactly you can make sure your deployments are going through via Azure build and release pipelines also. Okay, that one also we will see. The firstly, let's go there and connect to the VM. Okay, let's connect to the virtual machine. And your virtual machine, I think I configured already here. I think this is your virtual machine. Let's try to connect this way. So I'm just launching this one via terminal, team. Okay, let me close Visual Studio Code also. I'm just going and using a terminal approach. Okay, we have a terminal approach also. Let's go for the terminal. Okay, all right. So I'm just going here. I'm just closing this one, and you just take the connection SSH. You know the connection already. Just come here. SSH Azure user at the rate IP address, right? So it's asking the password. Just give the password. Okay, that's all. So you're in the VM. Okay, you're in the VM. Now what you need to do? kubectl get SVC. Okay, that's the thing first you need to do. Kubernetes cluster. I think it seems to be on. Okay. Metrics. I think this issue is a little bit different. It's okay. Ignore this one. Okay. Ignore this one, Tim. Okay. I don't think so. It's coming because of our issue. Okay. I think it's coming because of the cluster. Okay. Don't worry. But again, anyway, your services are listing. Okay. Let me double check the above issue. Why it's some information is coming up. Okay. All right. Once you are done with this particular thing, Tim, you have a lot of examples here already. I already placed here. Okay. You can refer these things also. Not an issue. The first and foremost thing, what you need to do, let's simulate the Microsoft example here. Okay. You just come back here, Tim. There they are talking about dynamically provisioning a volume. Scroll down, scroll down, scroll down, scroll down. Okay. So once you scroll down, so yeah, there I believe this is what exactly the starting point. Just took the storage less. Just go back to your case, and I'm just creating one folder. Okay, make directory. I'm just taking here dynamic volumes. Okay, or something like that. Okay, and cd dynamic volumes. Okay, just go there. And first and foremost thing, and firstly I think what they are trying to create a specific camel. Let's use the same model. Okay, same name, so that the process will be very easy for us. And just copy this one and just paste over there. That's all you need to do. And just colon wq exclamation key enter. That's all. So your storage class being created. Next one, what exactly you need to create? You need to create the percent volume climb. Okay, you just copy this particular percent volume claim also. They're talking about an example, Azure file hyphen pvc.aml, right? Vi Azure file pvc.aml. Just open this one and copy this particular context and just go there. See, they're using the reference of your storage class name which you created just before. And also you are climbing 100 GB of storage dynamically. Okay. A file will be created with 100 GB storage. And that's the thing exactly will happen. See, you're ready with these two things, and they're just telling just submit. Okay, fine, Tim. So now I'm just going there. Okay, you can submit. Okay, for example, kubectl apply. For example, you can submit from outside also. For example, I just want to show you an example for you. kubectl. I'm just taking pwd. Okay, all right, and also kubectl apply hyphen f. So what exactly the, see, take the dollar tilde symbol slash. So whenever you give that model, it automatically it doing tilde and slash, it will find where exactly the things are sitting. Each and everything it will point in. So that's exactly the interesting fact over there as part of this one. Okay. Sorry, yeah. I think I just placed okay. That's fine. See now what exactly the thing you attempted, you just give the directory. You have not given any other thing. You just give the directory. So kubectl-f or just give the directory name. What are the things are sitting inside this particular folder? Everything got submitted. Okay, everything got submitted. That's the thing exactly. The thing happened. Now the point what you should understand. So I'm just going a bit here. kubectl get pvc. Okay, get pvc. I'm just submitting the pvc team. Now the first and foremost thing, okay, let me elaborate this one so that I think you will be very clear. This is what the 26 seconds before. Okay, this is what exactly our case. And the pvc name is my hyphen azure file, makes sense, and it is bounded to a volume called pvc before, or some blah blah blah, some pv name. This is what the pv name, percent volume name. And 100 GB is on the access mode is rewrite many. That's fine, team. Now I want to describe more on this particular PVC. Okay, how to do that? The kubectl get PV. You just go there and just type PV. See, this is what exactly your percent volume. Okay, your percent volume, team. So now let me just zoom out. Okay, and also just expand the screen so that your lines will be very clear. Okay, so now firstly, what exactly the point I'm highlighting here, team? Okay, so for example, let me expand this one a bit. Yes, awesome. See, this is what exactly I'm talking about. So 40 seconds, 41 seconds means this is what the main, exactly the point which I'm trying to highlight. This is the PVC, right? Let's go there and just describe this one, team. kubectl describe PV. I'm just giving that particular thing. When you describe PV, if you open this particular PV thing, okay, what are the thing you just described? Now I want to show you where exactly this PV got created. If you see this particular PV thing, I think there you can see volume handler. If you see the volume handle, meaning that where exactly this particular thing is being sit. For example, you and the MC resource group, I told you already, MC resource group is the resource group which got created along with your cluster, and followed by under the storage account, followed by this is exactly your file share. So that's the thing exactly it's created, team. Okay, awesome. Now to double check this one, you can go back to your document. So you can go back to the portal and you can search for the storage account. So this is what exactly storage account, because when you never prepared with the storage account, no. If you see the static example, you have created a storage account, you have created a percent volume, you have created a percent volume clamp, each and everything you prepared, and storage account key, everything you exported. But in this case, I don't think so. You're seeing some specific to that. So now just go for the storage account. What are the storage accounts you have at the moment? and just go there, just search with the storage account. This is the what the storage account which been created dynamically just before. Now, if you open this storage account, this is a dynamic storage account team. That's why this name is not uncontrollable. This name is uncontrollable team. You cannot control this name. It got provisioned automatically. Okay. And if you scroll down, go for the file share, and you can see a file share where you're saying, okay, PVC got created. This is what exactly the point. This is what exactly PV. This is called PV. Don't think like PVC means person. This is called PV. Percent volume, your storage capacity, 100 GB. That's what exactly the point you should understand. So once your task is done, team, I'm done with my part. So now what exactly the next important fact here? So once everything is good, because volume climb is also got created, now you submit it and you are prepared. I think we already double check this case. Okay, everything is all right. And finally, you just need to create a deployment. That's all you need to do. To do the deployment, copy this particular thing, team. I'm just copying as it is. Just go there. There, I think let me zoom in a bit. I think the size is not really enough for you to see. Just a moment. Okay. Okay, all right. So once what exactly I'm going to do here, team. Okay, I'm just clearing the screen and I'm just going there. Sorry, huh? So I'm just creating a VI pod. Okay, a VI pod. Maybe let's go to the same directory. Okay, so that I think I can also share the same directory to you, team. Okay, so there I think we just took the example. Where is this one? Mm, and project Azure files, preview examples. No, not preview examples. We have created a directory, right? In dynamic volumes, okay? CD dynamic volumes, okay? Dynamic volumes. Let's go inside, and I'm going to create one more pod.aml. So this is just a pod team, okay? Not a deployment, just a pod. So now you just copy this particular thing. You just come here, just paste over there. Now, interesting fact. Only catch here is you are using a volume section, okay? You are using a volume section. Under the volume section, you are using the person climb reference. This is what exactly the climb you just created, team. Okay, please understand. This is the climb exactly you created just now. And whatever the climb name you defined here, the same name you should use here for the mounting. Okay, as it is Unity queue. And this is your container path. Please understand. This is your container path. Container path, team. Please note it. Please take a note. Not a file share path. It's a container path. Okay. Once this is done, WQ exclamation hit enter. That's all. Now finally, kubectl apply -f pod. Okay, I'm just submitting this particular thing. Pod got created. Awesome. Once the pod got created, I'm just going there. I'm just going there and double checking whether the pod came up or not. Now, if you see this particular thing, team, I think the pod is under running state. That's awesome, actually. So now, interesting fact here is okay, kubectl. See, if you open your deployment, sorry, pod YAML team, you created this container path. You are asking container, please refer this particular container path, meaning that it will create this directory. Now we will go there and see whether directory got created or not. Kubectl exec -it. Okay, I'm just taking this particular part. Okay, and hyphen. I'm just going inside. Just a second. Huh? Kubectl exec-it. I think. Sorry. Yeah. Exec-it. I'm just going there. Hyphen sh. Okay. Hyphen sh. Hyphen it PO. Don't think so. You need to represent the PO. Second team. Just a second. I think in last session we attempted this already. Just a second. Refer the history because I attempted in the last session already. Okay, so let's go there and just double check the exec command. Okay. Okay, kubectl exec, right? Kubectl exec. Yeah, I believe this is the one, right? Yeah, exec. I think correct only, right? My pod -. Okay, space sh. Okay. Okay, so I'm just copying the same command team. I'm just copying the same thing. You just go there, and especially, I think that is also my part only, right? My part only. I believe additional space is missing for me. I think there is a space in between team. Sorry, I missed it. Okay, so once you are here, team. Okay, that's awesome. No worries. Okay, as part of this particular thing, I'm just going to the directory. What are the directory? The container is different. Go to this directory /mnt. Okay, see, you are just coming here. See, now the point you need to understand here is this is what the container directory where your container will write some valuable information inside. Now the advantage of this particular thing, whatever container is writing in this particular place, same thing will be reflected in your storage account. For example, vi log.txt. So for example, log.txt. For example, I'm just taking, okay, I'm just going, okay, here I'm just giving a sign here saying that, okay, uh, dynamic volume provisioning, okay, volume provisioning, for example. I just give some name here, okay, provisioning, okay, just give some name, okay, and just escape colon wq exclamation hit enter. See, you created a log.txt. Now, interesting fact here is just come back here, open the storage account, and you go for the file share. What are the file share you mounted? In this particular file share, just click on the browse. See, log.txt got created. If you open this particular log.txt also, I believe you can comfortably check this particular information whether really the same information got synced or not. If you go there and just see dynamic volume provisioning, interesting fact is not that one. See, you know very well that pod volumes are ephemeral, right? So if today your pod is getting created and it got terminated, but any of the cost from the cluster side, but you should not lose your data. That is what our target, right? You should not lose your data. So to fulfill that one, what exactly I'm just going there. Let me go there and just exit out of this particular thing and let me list down the parts one more time. Okay, kubectl get PO, and this is the part exactly kubectl. Delete PO. I'm just deleting the part team. So meaning that when I delete the part, automatically whatever the log.txt I created inside the part, it will be out. It will be out actually. To be frank, it will be out. But 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 the mounting path which we created, I mean, PV and PVC bonding. The PV and PVC bonding really help you at the moment. Okay, what will happen? Now part will come again, right? No problem. Part will come again. So, oh, sorry, it's not a deployment. That's why it will not come automatically. If you refer this particular model theme, it's a pod, kind is pod. The kind is pod, it will not come automatically because this is not controlled. If you keep deployment is controlling the pod. You can refer the architecture. Sorry, if you can refer the hierarchy. If you recall team, pod followed by replica followed by deployment. That is what exactly we learned in one of your initial discussion. I might have placed that one here. Okay, so that is what exactly you should be here also. Okay, somewhere here. Okay, docker file, docker. Yeah, this is the one I'm talking about, team. Okay, container followed by the container followed by the pod followed by the replica set, replica followed by the deployment. This is what exactly I'm just highlighting. So the interesting fact here is, since you directly deployed the pod, it will not be replicated or it will not be redeployed automatically. That is not happening, team. Okay, this is only pod. So it's okay. Now mind, what I will do, I will resubmit the pod. Okay, kubectl apply -f pod. Okay, just submit this one. So now pod got created, team, again. Now the interesting fact here is, now you just go there inside the pod. Okay, what same pod name only, right? You can go there inside the pod. If you go there inside and cd slash, okay, what are the path you are just referring here? There is a path which you are referring, right? Slash mnt azure. So I'm just referring the same thing. You just have to see log.txt exists. How? This is a fresh pod, right? And also you can double check the log information also. See, same information is there. So point you should understand here is, though your pod dies, or your cluster failure or your node failure, doesn't matter, your data is safe. Pod dies, node dies, cluster failure, doesn't matter, your data is always safe. You can mount this one to the newly created cluster also. Even that is also possible. Okay, even that is also possible, team. For example, you have placed all your valuable information inside the file. Now all of a sudden this cluster moved to the failed state where you are unable to recover. Then what should we do? We just lose your configuration only, not the data. You should understand that. So you can set this configuration setup on the new cluster one more time, but when you set up and when you provisioning everything, fresh file will come, which is of no use. So you should connect this particular existing PV to the new cluster. That makes sense because that is what exactly the expectation, right? So in this way, you need to move on.
Thank you for the session. See you in the next part.